Okay, so with this lecture, we're going to talk about sensory receptors. Okay, and we're going to actually kind of do this by talking about 3 types of motor neurons and then 4 different types of sensory receptors. But just to start, I don't think I mentioned this earlier, so I want to make sure I mention it now. There's many different factors that affect force production. Okay, and there's something called autogenic inhibition that we're going to talk about here in just a minute. Muscle structure, which we've talked about a little bit. We'll talk about some more. Agonist and antagonist muscle groups, and then we'll end with joint biomechanics. And so for some of you that are taking PE 380, this will probably be a little bit of review or tie into what you've talked about, or at least will prep you for things that Dr. Finch will talk about. Okay, now there are 3 main types of motor neurons. Most of the time when we're talking about motor neurons, or what you think of when we're talking about motor neurons, are alpha motor neurons. These are large neurons that activate what we call the extrafusal muscle fibers, or just what you think of when it comes to a muscle. These are the ones that stimulate force production. Okay, then we've got beta motor neurons, and these activate or innervate extrafusal and intrafusal fibers. And we're going to talk about some of these intrafusal fibers here in a minute. And those are sensory receptors. Okay, and then you've got gamma motor neurons that only innervate intrafusal fibers. Okay, so you've got alpha, which is just the force. You've got beta, which activate the force and the sensory, and then gamma, which just innervate the sensory. Now, with these sensory receptors, there's 4 different types. We've got muscle spindles, Golgi tendon organs, Pacinian corpuscles, and then Raffini endings. Okay, so we're going to talk about each of these, and each of these you're going to talk about in lab as well. So we're just going to go from here. Some of what I talk about, or the examples I use, are probably going to be similar to what you learn about in lab, but that's all right. We'll reinforce here. Okay, the other thing I want you to notice is that the extrafusal fibers are the ones on the outside. Okay, so actin and right here, it's red so it's not circling real well. Okay, so actin and myosin, think of that. And then we've got these sensory receptors kind of buried deep in the muscle. Okay, so muscle spindles. Now we talked about these in physiology, and muscle spindles detect length and the rate of change in length. Okay, and the rate of change is more important. So how fast is the length changing? Okay, and so when muscle spindles are activated, they decrease muscle stretch. Okay, so for example, they cause patellar tendon knee reflex. All right, so for example, when you get hit on the knee at the doctor, okay, that stretches out your quadriceps. Okay, now it doesn't change the length very much, but in that instant, the rate of change in length is very high. And so the muscle spindles are activated. It has to be activated by a relatively large stimulus. And what that does is that has a big impact in the muscle. And so we have knee extension. Okay. Now, gamma neurons that we talked about a minute ago help keep the spindle inside your muscle taut. And so during normal contraction, we don't want these to be activated. So these gamma neurons inhibit muscle spindles, and that way we don't have all these weird contractions going on. And this is what we call autogenic inhibition. Okay, so we really only want these muscle spindles to be activated when we have a high level of stimulus. Now, kind of on the other end of the spectrum, we have something called the Golgi tendon organs, or GTOs. And for those of you that don't know, this is a car called a GTO. That's why it's there. And so these are similar in that they sense tension and rate of change in tension. Okay. Now, unlike muscle spindles, when GTOs are activated, they actually inactivate the muscle. So they cause muscle relaxation. Okay, and the goal of a GTO, just like the goal of the spindle, is to prevent injury. Now, in an untrained individual, these are activated relatively soon, okay? But in a trained individual, these are activated later. And so the trained individuals are more likely to get injured than untrained individuals. For example, if you pay attention to professional sports, you'll hear about guys tearing their quads or their hamstrings or whatever. But when was the last time you heard about just, guy that lives in your neighborhood tearing his quad? it doesn't happen very often, and that's because of GTOs. So an example of where your GTOs are being used is, let's say that you're holding on to, someone asks you to hold a box, and so they give you the box and it's really heavy. Okay, what do? Oftentimes you just drop it. It's too heavy. It'll injure you to hold on to it, so you just let it go. Not necessarily the best thing in the world, but that's what would happen. Okay. Then we've got these things called Pacinian Corpuscles. Now, these are mechanoreceptors in the skin, and they respond to changes in pressure and deformation and things like that. They sense high-frequency vibrations and changes in pressure, but they're activated with relatively low stimuli. They cause small amounts of change. Okay, and what they do, they are similar to muscle spindles in that they activate the muscle. Okay, and what we mean by that is low stimulation will cause them to be activated. Now, just imagine, and I actually had this conversation with my wife earlier in the week when she got back from South Bend with my daughter, is that she said, man, I hate it when I drive in the car for a long time because I'm always stiff when I get out. My muscles are stiff and sore and that sort of thing. And I said, oh, well, this is why. And I explained it to her. So you have these Pacinian corpuscles that are activated that cause muscle contraction. Okay, and if you think about it, when you're in a car, the car ride isn't perfectly smooth, but you don't necessarily feel like you're bouncing all around. The Pacinian corpuscles help with that. And so they're activating these muscles. And so then when you get out, you've got these muscles that are tired and stuff. And so that's why you feel stiff. Okay. They're relatively fast adapting. The last one is something called Raffini endings. All right. Or Raffini corpuscles. And so these also sense low frequency vibrations and stretch. They cause small changes as well. They're slow adapting, but what they do is, instead of activating the muscle, they inactivate the muscle. And so this is where massage comes into play. Okay, and this isn't like Graston or something like that, but this is like deep tissue massage. You're activating these Raffini endings or corpuscles, and what they do is they inactivate the muscle. In other words, they allow the muscle to relax. Okay, and so that's what we're trying to take advantage of there. And so we're going to end our sensory receptor video with that.